would like to start with nuclear power generation, and then we'll try to finish wind power generation. And your online class will be on Thursday, right? Thursday I will touch on power generation. So the problem is, I need make Wi-Fi. I cannot show to all the video, so I think I will show you during online class. Ya, itu tak boleh hari Khamis tu. Tak ada suara, no voice.
Yeah.
Grup satu ni okey semua. Okay, we start with nuclear power generation. Okay. In the syllabus power system tadi, there are 6 different types of power generation that we all must know. Okay, I already touched on hydroelectric power generation and thermal power generation. Okay, for today I would like to start with this nuclear power generation. So in nuclear power generation, nuclear fission takes place when a free neutron strike the nucleus of fission materials such as uranium. Okay, uranium. Sometimes it can be plutonium. Okay. So the impact of the nucleus split into several particles. Okay, you can see that this figure. Okay, when they have a free plutonium and then strike the uranium here, and then it can split into several particles. Let's say neutron free 2 to 5 free neutrons, and then we have the cesium here, and then we have the Superman radioactive krypton. Superman anda apa ni? Superman ni? Kryptonite, radioactive krypton. And then during this impact, it can releasing energy which is manifested as a heat. Heat. Sometimes we call it as a thermal energy. Okay. From that, in this process, some of the new neutrons release collided with each other. Dia berangkat antara satu sama lain. Each other fusing nucleus is also split and chain reactions set up. Chain reactions apa berapa? Keanu Reeves punya movie. Chain reaction. Kita dah masuk sikit cerita. Yeah. Chain reaction. Okay, then the plant containing the fissile material is called a reactor or pipe. Okay, there are two different terms there. Reactor or pipe. Reactor, what reactor produce? The reactor produce heat or thermal energy which must be converted into energy via heat exchanger. This exchanger sometimes we call it as a steam generator. So turbine and then the generator. You know that we have to convert into one form of process into another form of process, one form of energy into another form of energy. So for this nuclear power generation, we have to convert from thermal energy to steam energy to mechanical energy to electrical energy. Ini waktu proses kan. So there are many sort of process there. We need to convert from one form of energy into another form of energy. So the reactor or pipe produce heat which must be converted into energy. And then there are many different types of reactors with different coolants and moderators and different types of fissile fuel. Fissile fuel sometimes they are put into the fuel rod in reactor or pipe. So fuel rod sometimes can be uranium, sometimes can be plutonium, which is radioactive. So there are two types. There are two types of general reactor. Number one, pressurized water reactor. Number two, boiling water reactor. Okay, yeah. Definitely different between these two types of water reactor. Boiling means that we need to boil. We need to boil the water reactor which consists of radioactive component in the reactor or pipe. But this pressurized water reactor is only depend on the pressurized. Heat, increased pressure, high temperature. But this one it consists of three systems. You must have first system what we call as we call as primary system. Electrical system. Primary system, and then this one is secondary system. Primary, secondary, and then tertiary system. Tertiary system is the third one, which is the condenser. Condenser we can convert it from steam energy to the liquid Clear? Boleh ikut kan? Can you follow me? Okay, there are primary circuit, secondary circuit, and tertiary circuit, which is the condenser here. So there are three different. So in fact, this one you have to pump the water, high pressure water, and then going to the reactor pressure, which is the thermal energy is released here, and then going back to the steam generator here, which is heat exchanger occurs here. So there are steam energy there, and then we are going to the circuit, the secondary circuit, which is the high pressure turbine. Okay, the high pressure turbine, which we need to convert it into steam energy to the mechanical energy. So then mechanical energy here, we need to couple to the generator, in which we need to convert it from mechanical to electrical energy. That is the process there. So there are certain functions that you need to know, like this one, moisturizer separator. Moisturizer separator, we remove suspended water particle. Reheater, which means that you need to reheat the expanded steam from the turbine. And then going to the condenser, you need to convert it from the steam energy, which consists of the mixture of water and steam. Okay? In the secondary circuit, the mixture of water and steam, then you need to convert it into the liquid. So then you need to have this one, condenser pump, and then feed water heater and go back to the heat exchanger here. So ada berlaku proses penukaran tenaga daripada satu tenaga ke satu tenaga lain. Semua orang tahu. Okay. So there are tiga sistem lah, primary system, secondary system, and then the third one, the tertiary system. Okay, this is the schematic diagram showing that how pressurized water reactor works. Okay. Okay, then the second water reactor, which is boiling water. Boiling water is just, it only have one system only. It cannot be divided into three systems, no. Only direct cycle steam. Dia satu proses dia. Satu circuit sahaja, satu sistem sahaja. So direct cycle steam generating system in which the reactor coolant is permitted to boil. Dia ada boiling. Okay, boiler dalam reactor core or pi core. Dia ada boiler untuk nak panaskan dia, untuk nak releasekan dia punya thermal energy, heat energy. In which the reactor coolant is permitted to boil in the core and resulting steam. Resulting steam to the flow. They can flow and then going to the turbine. Turbine from steam, we need to convert into mechanical energy lah, kan? Untuk turbine tu. So from turbine, then we are going to the moisturizer separators and the steam dryers. After passing through a suitable heat cycle, the steam is condensed. Okay, the steam is condensed and then converted from steam to the liquid, and then go back to the steam generator. From the condenser is pumped through the full flow polishing devaluators, feed water heaters, and then back to the reactor or the pipe of the core of the nuclear power plant. Devaluation is actually we need to separate what you call in English impurities. We need to filter the water from the impurities. Impurities itu masuk dalam bahasa Melayu berdasing. So this is the schematic diagram showing the boiling water reactor. Just you need to have this one system only. There is a difference between the pressurized water reactor and the boiling water reactor. So all of you need to know the difference between these two, in terms of the function, in terms of the process, in terms of the schematic diagram. You'll be able to draw the schematic diagram and then explain the physical working of the nuclear power plant. Saya yang tengok video. Dalam video dah detail. Setiap frasa saya memang kelas pun dia awal ni. Tak pernah lah dengan saya rasa saya habis jam setengah. Selalu saya habis 2 jam. Sampai habis masa lecturer lain. Lecturer lain memang tak tengok. Ini lagi. Lalu 2 jam lebih. Saya juga. Tak pernah ni saya habis awal. Hari saya habis awal. Clear ni? Okay, faham? Right. And then we're going to the next slide. is above geothermal. Geothermal power station. Geothermal comes from the two words, geo and thermal. Geo means that earth, bumi, earth, bawah tanah. And then thermal station buat tahulah location. Okay, this is the Iceland's Resident Geothermal Power Station 4 times 30 megawatt. So geothermal power is defined as the transfer of heat from the hot interior, daripada bawah tanah, of the earth to the cooler exterior. Dan keluarkan dekat sub, keluarkan dia ke cooler exterior, and then the heat originates from molten rock, magma, molten rock, magma, in the earth crust, kerak bumi. And then the water is then pumped to the surface by deep well pump. Pakai deep well pump, producing well. The water gives up its heat in a heat exchanger to heat a liquid to a boiling point, and then it is superheated. Then the steam is injected in the turbine. The condensate from the turbine is changed into the water. The water then gets cooled off in the cooling system. The cool water can be pumped back below ground to be treated by the earth. So this is the figure for schematic diagram showing that how geothermal power plant process works. Okay, then for the third power generation, this is quite interesting. Wind power generation. Okay, nowadays there are two types of power generation. There are two types. One is with the blade, and another one without the blade, which is bladeless. This one is open display. Once final dah kita dia tak ada blade. Kita ada blade, memang menarik. Sekali lagi saya tak tunjuk video. This is very frustrated. Okay, wind energy. The use of the wind as energy source. A wind energy system that transforms kinetic moving energy of the wind into mechanical or electric energy that can be harnessed for practical use. So the wind has been utilized as a source of power for thousands of years for such tasks as propelling shelling ships, grinding grain, pumping motor, and powering factory machinery. Mechanical energy, so we need to convert it from the wind energy to the mechanical energy by sails for transportation, sailboat, and other purposes such as grinding grain and pumping water. And then we can also convert from wind energy to electric energy, which is we try to harness the wind for electricity generation, which is currently the most widespread use of wind energy. So the wind power plants or wind farms sometimes got a cluster of wind machines used to produce electricity. A wind farm usually has dozens of wind machines scattered. Scattered means that berselerap. Berselerap here into the various locations over a large area. Unlike power plants, many wind plants are not owned by public utility. Public utility company ni macam TNB, Tenaga Nasional Berhad, Sabah Electricity Sdn Bhd, SESB, or SESCO, Sarawak Electricity Sdn Bhd. That one is the public utility companies. Instead, they are owned and operated by business people who sell the electricity produced on the wind farm to electric utilities. These private companies are known as independent power producer macam YTL company macam Malakov. In Malaysia, do we have the wind turbine power plant? Ada. In Malaysia, do we have wind turbine power plant? Ada. Mana? Sabah lagi tak ada. Kat mana? Sabah betul. Sabah kat mana? Pulau Terumbu dan Layang. Pulau Terumbu dan Layang kat mana? Pulau Terumbu dan Layang Sabah. It can produce around 150 kilowatt. Turbine. Ada satu lagi kat Malaysia kat mana? Ada satu lagi kat Malaysia kat mana? Ada kat mana? Pulau Pontian, pandai. Pulau Pontian dekat mana? Kat mana Pulau Pontian? Tak tahu. Terengganu. Okay, pulau panjang tu berapa kilowatt? Berapa?
Hah?
How many watt they can make you use at Pulau Panjang? 100 kilowatt. 100 kilowatt. But that one is hybrid together with the solar. They have 100 kilowatt wind turbine, 100 kilowatt solar. They have kita sama 150 kilowatt only wind turbine. So in fact, there are some reasons that you cannot generate electricity from the wind turbine. So because of what? Because of the wind speed. The wind speed in Malaysia currently 2 meter per second, which is very slow. Slow yang amat. Dia kena dalam 4 meter per second dah ke atas. Okay. Wind turbine kat Malaysia. Tapi kalau nak survey dia mana dalam negara tu, mudah untuk Google je. Berapa banyak dia produce electricity. Okay, independent power producer. Then, okay, we're going to this one. Operating in wind power is not as simple as just building a windmill. Windmill apa dah? Windmill. Kincir angin. Dia tak mudah. Tapi windmill, we doesn't use a gearbox or generator. Tak perlu. Kan? It just simple je. Jadi kincir angin. We plant owners must carefully plan where to locate their machine. Mana? Nak bina power plant wind turbine, kena fikir tempat mana kita nak letak. Itu yang kena fikir. One important thing to consider is how fast. Laju ke tidak wind speed. How fast and how much the wind blow. Itu persoalannya. As a rule, wind speed increases with altitude. Altitude, ketinggian. Kalau wind speed underground okey lah. Kalau ground okey tak? Wind speed dah laju tak?
Tak.
Pasal kurang kan? Dia mana kata dia akan increase kan? Dia increase sampai ke atas ketinggian altitude. And over open areas with no wind breaks. Good sites for wind plants are tops of smooth, rounded hills, open place or shoreline and mountain gaps that produce wind fatigue. This speed varies throughout the country and it can also varies from season to season. Sekarang tengok dua jenis. There are two types. We can classify wind turbine into two types. Number one, vertical axis wind turbine. Okay. You can see in this figure, we have a part A here, which is upwind horizontal axis wind turbine. Upwind means that apa dia datang ke arah kita, angin. Upwind, downwind belakang nature. Downwind horizontal axis wind turbine. Then we have another type, which is vertical axis. Vertical axis we have generator gearbox. This is below the ground here. So we have the guide wires here in order to support, in order to make sure the rotor blade is stable. This one is rotor blade, and then this one is wind. Wind can be any direction, either from left, from right. It's quite different from the horizontal axis wind turbine. So most are horizontal axis wind turbines, but there are some with blades that spin around a vertical axis wind turbine. Okay. In terms that, let's say we are going to do some troubleshoot. Which one is better? In case we have a breakdown generator gearbox, which one is better? Which one is better? Is this one better or this one? C, right. C is very better because we are there's a new one and the below one, which is very smooth. You can troubleshoot that. But this one you need to break it down. Katalah 120 meter pun. Turun. Kan? So dia nak troubleshoot dia. Okay. Then when we have these two types of wind turbine, vertical axis and horizontal, of course we have the pros and cons. Right? We have the advantage and disadvantage. So this is the advantage and disadvantage of vertical axis and horizontal axis. Vertical axis don't need any kind of yaw control. What's yaw? Yaw control. Tangan robot. Using a standing here, and then the wind direction is towards me. Okay. And then the rotor blade is turn. Yeah? That's rotate at slower and low speed. How about this one? Let's say that the movement of the wind is can be changed, right? Can be under condition. How can I go there? That's why we need your control, which is connected to the gearbox and coupled together with generator. How about that? Kalau wind direction ke sini, wind direction sini tak apa kan? Blade rotor tu boleh pusing, tapi kalau dia datang sini, macam mana saya dapat? Dia tak sama macam ni, macam vertical. Sebab tu kena ada your control mechanism. It attach together dengan gearbox dengan generator. Your control. Okay. The heavy machinery contained in the nature. Nature consists of what? Consists of generator, gearbox, and other mechanical components which can be located down on the ground where it can be serviced easily. The blades on the radius rotor as they spin around are almost always in pure tension, which means that they can be relatively lightweight and inexpensive since they don't have to handle the constant flexing associated with blades on horizontal axis machine. Okay. We know that the speed is quite slow. Okay, we know the speed of the wind turbine quite slow. But let's say that right now we have to produce the steam. Let's say we have to produce 50 kilowatt or 100 kilowatt. So when the speed is slow, the rotor is speed, dia akan pusing slow apa laju? Slow kan? That's why we need one thing that you need to remember. You need this component, gearbox. Why do we need gearbox? Yes, we need to increase the shaft speed from slow speed to high speed. Normally, for wind turbine, 17.2 RPM. Rotation per minute is 17.2. So we need a gear ratio that we need to increase from 1 to 90. To 90 RPM. So that's why we need to 17.2 times 90. 1,500 RPM, so that it can be compatible with the generator itself. Because we need the generator to convert it into electricity. Critical energy. You understand? Sebab tu kita perlu gear ratio. Tak ada gear ratio tak boleh buat. Sebab dia slow. And then the blade. The blade of wind turbine. The blade of turbine, the shape is like this one. The blade of the rotor, the blade of the wind turbine. It's not this rectangular shape or this one. This is the blade of the wind turbine, which is we have L4 here. L4. So in order to make it like aerodynamic, so we have to make sure the wind velocity and then the relative motion between the blade and the rotor can turn the rotor. It can rotate the blade of the wind turbine. So kita perlukan dia. Kita perlukan shape dia dalam bentuk berdiri F1. So the next thing is this one. Vertical axis turbine. The principle one being that the blades are relatively close to the ground where wind speed are lower. Okay? Power in the wind increases at the speed of velocity, so there is considerable incentive to get the blades up into the faster wind speeds that is higher up. Winds near the surface of the earth are not only slower, but also more turbulent. It's not stable, not turbulent, which increase stress on vertical axis. Low speed winds, vertical axis rotors have very little starting torque. In higher winds, when output power must be controlled to contract the generator. They cannot be made to steer the wind as easily as pitch control blades on high vertical axis wind turbine. So this is the figure here show the component of the horizontal axis wind turbine. You can see that this is the blade here. This is the blade. Then this is nose cone here, and then we have the nature here. The nature here consists of the component here, which is the gear ratio,
gearbox and then connected to the generator here. And then we have the main shaft here in order to convert from one form of energy to another form of energy. And then we have this one,
what we call as velocity sensor, anemometer. So what is the function of anemometer? Apa function? What is the function of anemometer? Velocity sensor. It measures the wind speed and the direction. Direction of speed. It measures the wind speed and the direction of the wind speed. Dia measure dua benda tu. Anemometer ni macam yang kita guna untuk kaji cuaca.
velocity sensor. Jadi
Apabila angin dekat sini, kan kita tunjuk kan. Kita tunjuk kan. Dengan cara kita akan tengok pada velocity sensor. Dia akan buka. Kalau wind dekat sini, dia akan buka lagi. Sini, blade tu dia akan buka. Dia akan fokus pada ikut direction. Direction arah angin itu. Untuk kegunaannya, anemometer ataupun velocity sensor.
So horizontal AC motorbike are most commonly used today. The wind blows through blades which convert the wind's energy into rotational shaft energy. The blades are mounted on top of higher tower to a drive frame, usually with a gearbox that uses the rotational energy from the blades to spin magnets in the generator and convert that energy to blade current. So the shaft, drive frame and generator are covered by a protective enclosure, what we call as latch. So electronic and electrical equipment, including controls, electrical cables, ground support equipment, and interconnection equipment control the turbine, ensure that the maximum productivity and transmit the electrical current, and then it's going to the substation and transmission line.
So let's say
We need to determine the power of the wind turbine. So we need to consider a packet of air with mass M moving at a speed v. This is the kinetic energy here. Kinetic energy we know the basic formula. Half multiply with the mass and then multiply with the velocity. Half mv squared. So since the power is the energy per unit time, okay, the power is the energy per unit time. The power represented by a mass of air moving at velocity v through the area A near B. This one. Energy over time, and then we have kinetic energy here. Half mv squared divided by time, and then we have half m over t multiplied with the v squared. So
from there we have the equation number 2.
Sorry, equation number 1. Equation number 2. The mass flow rate, which is m dot here. The mass flow rate through area A is the product of the air density rho, and then speed v and cross-sectional area A. So the mass passing through the area divided by the time, which is equal to m dot multiplied equal to rho density of the air multiplied with the air with the area, and then we multiply with the velocity. So when you combine, we substitute this equation here, equation number 2 here, m dot equal to density of the air multiplied with the area multiplied with the velocity. We put it into
Equation 1 here.
and then we can get this equation 3 here. Equation 3, the power of the turbine equal to half multiplied with the rho, the density of the air, multiplied with the area of the air, and then multiply with the v to the power of 3 here. So in SI unit, standard international unit, PW is the power in the wind, which is we measure in watt. The density of the air, kilogram per meter cube, which is normally at 15 degrees Celsius and 1 atmospheric pressure. Rho equal to 1.225 kilogram per meter cube. This is the fixed value there.
Bila dia tak berubah fix.
Fixed value untuk air density. Air A is the cross-sectional area through which it passes, which is in meter square.
Dalam meter square.
And then B is speed normal to A, which is in meter per second. This is the useful conversion in order, let's say
in the question we ask, given that in miles per hour, we need to convert it into meter per second. Dalam bilik macam unit pun akan ubah, kena ikut standard dia.
So they put the SI. Okay. Okay, there are differences. There are differences between the area of vertical axis and the area of horizontal. Horizontal, we are using this formula, area. A equal to pi r square. R we know is the radius, right? The radius, so d over d over 2 and then square, we obtain pi d square over 4. And then for vertical, the area is 2/3 multiply with the t here, the width, and then the height here. This is for the vertical. This is the difference between the vertical and the horizontal in terms of the area only. Okay, we'll have to take a break 5 minutes and then I will continue with this calculation. I know engineering, all of you tends to make calculation, right? Tak tahu awak minat ni, kalau betul ni dia pun boring. Ya, sorry pula saya belajar dulu, tak tahu. Okay, I'll take a break 5 minutes. Saya cepat sangat tadi. Okey, kat lagi. Ibu kau, komen. Cepat sangat.
Laju sikit tu.
Laju sikit lagi boleh.
Kalau kita lagi banyak buat lah. Bodoh. Kira dah apa? Macam tu kita orang pilih. Sebab tak nak macam ni. Agak tu dah. Aku tak cakap kau. Aku cakap. This is Shema. Macam mana? Next time. Secretary. Oh. Ni tak tahu kalau cara pergi dah. Cari entar dah. Jaga. Apa jangan buat macam tu. Dia bagi panas. Kalau air tu buat satu.
Okay, we have a lesson technique. Satu A ni. Pastikan buat awal.
Allah. Dia lebih besar. Oi, cantiknya. Oh, tapi
Semua lab anda kita open ended lab. Open ended lab dia akan masuk masa sebab long report. Yang lain semua kena hantar. Hantar on the spot. 2 jam pun hantar. Hantar rumah.
wow. Jadi, 我是不知道。你好，by group ke apa? By group ke apa? Nanti ke? Hah? 自己啊？哦，自己啊，individu. Pandai aku. Apa 去去啊？Apa? 是。Tulis apa? Ilmu apa ada kat? Ilmu apa tak buat baik. Ilmu ni kat Oh, yang ni respect. Respect ni. Punya macam ni.
Apa dia nak bagi video? You ada group satu saja assignment. Assignment yang presentation tu kan. You kena ada satu group 10 orang. Itu minggu depan tu. Gitu. You ambil nak 2 jam ada kereta.
Oh, tu dia kopi lah.
Kalau lambat sikit tak apa, you boleh hantar kat bilik saya dekat 4 level. Tapi you pastikan you boleh ada nama yang itu kena lah. Tak ada tu lagi tak boleh pakai.
Apa dia?